Christina here with another Blink Labs Catalyst Closeout video. We joined the Use Cases Minimal Viable Product Challenge with the idea of building Dingo, a Cardano node written in Go. This was built off our prior funded Catalyst work, and our approach stayed the same. No hype, just writing solid open source code that works. We focused on getting a reliable MVP out there with testing and documentation so the community can use it and build on it. With 291,800 ADA in funding, we had the time and resources to make that happen, and we're proud to share the results back with the ecosystem. The next part of this video will be a walk through the milestones, demonstrating functionality and completeness of our funded proposal.
Milestone 1 covered storage of blockchain objects. We are storing raw blocks, UTXOs, pool and stake registrations and deregistrations, as well as tracking the current protocol parameters through on-chain updates. To facilitate this, we created a hybrid database system using both key value and relational database engines to get the best features of both. We used Badger for block data storage and SQLite to store metadata about block content. Here we have our database framework with specific handling for different types of data. Each of them has functions for getting, setting, in some cases, more specific queries. We've got our metadata plugin implemented by SQLite that handles most of these data types. And our so-called blob database plugin implemented with Badger for storing, in this case, just blocks. Milestone 2 covered the node-to-node portion of the Ouroboros protocol, which allows a node to communicate with other nodes on the blockchain network. This includes TX submission for distributing transactions to the mempool of other nodes, chainsync and block fetch for distributing new and historical blocks across the network, and peer sharing for allowing discovery of non-registered relays. We also created a connection manager to maintain connections to multiple nodes based on a topology config. Here is the implementation of TX submission. It supports both server and client sides of the protocol. Peer sharing, which currently only supports the server side. Chainsync, and the accompanying protocol, block fetch. Milestone 3 covered the node-to-client portion of the Ouroboros protocol, which allows querying the data stored in a local node. This includes local state query for querying ledger data, local TX monitor for getting snapshots of the node's mempool, local TX submission for submitting transactions to get distributed to other nodes, and a simpler variation of chainsync for distributing blocks to local clients. We also implemented support for the UTXO RPC standard for interacting with the node. Here we have our server-side implementation for the local TX monitor protocol. Local TX submission. Local state query, which supports handling an arbitrary number of queries, which are handled here. This is all of the ledger state queries that Dingo currently supports, including things like system start from the Genesis config, the current block number, chain point, era history, and queries about UTXOs by address and reference. And here's the UTXO RPC server API implementation. The listen config, we've got support for each of the particular modules, similar queries to what we just showed, submitting transactions, and so forth. Milestone 4 covered acting as a transaction submission gateway. This includes accepting transactions via local TX submission, validating them against a set of ledger rules, and distributing transactions from the local mempool to other nodes. We also put together a demo showing building and submitting a transaction using only Cardano CLI and Dingo. Here we can see the large set of ledger validation rules that we implemented and validate all transactions against. They differ per era. These are the Shelley. As an example, here's Babbage. Some of them are reused from the Shelley era, such as this one, such as the withdrawal on a wrong network. Others need to be re-implemented for the current era, either because of change in logic or the protocol parameter shape. And here we have the Conway rules. Each of the sets of rules, of course, come with their own set of extensive tests against them so that we can validate that the rules are actually working the way they're supposed to.
The project has been a success. Dingo lives. We did face some challenges along the way, like transaction validation, which turned out to be much more involved than we had expected. But working through it gave us a much deeper understanding of how validation works in Cardano. We achieved all the milestones we committed to, and we're not stopping there. Development on Dingo continues. One of the next steps is adding support for running as a cloud native archive node. This work's actually funded in Catalyst Fund 13 and is already underway. We're grateful to the Catalyst community for supporting this work. Your votes and funding made it possible to bring Dingo from an idea to reality, and we're excited to keep building together. Thank you.